this is a muon. This hasn't come up a lot in past papers, but muon proper lifetime. So now T0, just in high atmosphere, travels towards Earth at relativistic speed v. Distance traveled by the muon in reference frame of the Earth. Okay, so this can be done in two ways, right? We can use length contraction, which is this formula. Or time dilation, which is where this is proper time in the muons, and we have the muons proper time, right? So this is in the muons stationary reference frame, and this would be the dilation that the muon, the time dilation from the Earth's reference frame. Relativistic reference frame. And so time should dilate, which means from Earth, it seems like the muon is taking longer time, right? That's why we can see the muon when ideally we shouldn't be able to see it, right? And so if we use this formula, T from Earth is equal to the Lorentz factor times proper time, which is just T. And so we know now we want to find B from Earth, right? Distance. So then we just multiply by V, which is the relativistic speed of the muon, which is just V from the reference frame of Earth. So everything is in terms of the reference frame of Earth, and we have the Lorentz factor, which just becomes 1 over 1 minus B squared over C squared. And so we can already see it's D, right? Now, another way to do this is using the length contraction formula, which we have here. And so, but the thing to remember is that we have to flip the reference frame. So let's draw a diagram actually. We have the muon in the atmosphere. And then we have Earth. And this from Earth, this length from the atmosphere to Earth is set, right? It's a stationary, it's the proper length. Now the muon is traveling towards Earth, so for the muon, Earth is moving towards it, right? It's contracting, the length is contracting. So this is the L, and this is length contraction, or contracted length. So the distance is getting shorter in the muon's reference frame. muon's moving reference frame, right? The Earth is stationary, and so proper length is the distance from Earth to the atmosphere. And so we can use this formula. Let's move down a bit. Let's just move this. We have L, which and we have proper length, which is of Earth. So this is the muon. And the question is asking the distance traveled by the muon. And the Lorentz factor is down, so then the root comes up. So we get this 1 minus v squared over c squared. And we want L Earth, right? We want the distance traveled in the reference frame of Earth. So we get the same thing, L muon over 1 minus v squared over c squared. And L muon is just vt, right? The relativistic speed times the proper time of the muon in its own reference frame over this. And so the answer is D for that as well. So you can use both methods, but remember to flip the reference frame and you should get the right answer.